disproportionation reaction and let's solve it. So I told you what the disproportionation reaction are,
Yes, sir.
and we had given an example of the disproportionation reaction of chlorine.
Yeah. Yes,
So
sir.
let's talk about a disproportionation reaction.
Yes, sir.
Just a minute.
Yeah.
Okay. Now, let's talk about a reaction that Cl2 plus OH minus gives you Cl minus plus OC Cl minus plus ClO3 minus. Okay?
Yes, sir.
Okay. So now let's try to balance it. I think, Rohan, you can see it clearly.
Yeah. Yes, sir.
Okay. Now, having talked about this reaction, let us do it this way. We find that OH minus is just the medium.
Yeah.
Now what we do is we write Cl2 twice because Cl2 is the oxidizing agent as well as the reducing agent.
Yes, sir.
Okay. This gives us Cl minus and ClO3 minus. What we now consider is that this Cl2 is giving us this Cl minus, while this Cl2 is what's given us ClO3 minus.
Yes, sir.
Okay. Here, what's the number of electron change?
1
Two.
minus 1.
Two. There are two chlorines.
Oh,
Okay. What would be the electron change here?
sir, 10.
Perfect. 10 electrons. Now, what's the LCM?
Sir, 10.
10. So, what do we need to do here?
Multiply by 5.
Perfect. And here it will going to remain 1. Now, you balance this with respect to this and this with respect to this. So, here we have 10 chlorines here. So, you make it.
Yes, sir.
Here you have 2 chlorines. You make it.
Yeah.
Okay. Now, we have balanced the chlorines. Now, we need to balance oxygens.
Yes, sir.
How many oxygens here? 6.
6.
So, we make it 6H2O. Okay.
Yes, sir.
Now to balance hydrogen, how many hydrogens here? 12.
Yeah.
And here I need to put 12
H,
H2O
sir. Oh,
minus 12 OH minus. This 12 OH minus I can take out here. And this 12 H2O I can cancel out. I can cancel out 12 H2O and make it
6.
6 H2O.
Yes, sir.
Okay. So I'm going to get the equation as this would be added up 6Cl2 plus 12 OH minus gives us 10 Cl minus plus 2 ClO3 minus plus 6 H2O. Now, if I wish, I can just divide the entire equation by 2 and make it 3Cl2, 6 OH minus, giving us 5 Cl minus plus ClO3 minus plus 3 H2O. And now I need to check the charges. Here it is going to be minus 6. Here it is minus 5 and minus 1, total minus 6. The equation is balanced.
Yes, sir.
Is that clear?
Yeah.
Anything you would like to ask here?
No, sir.
Okay. Should we balance one more equation?
Yes, sir.
Okay, this time you are going to balance it.
Yeah.
Okay, and the equation is straightforward. P4 plus OH minus gives PH3 plus H2 PO2 minus. Balance it.
Sir, I'm getting that the balance or something.
Hmm.
Uh, sir, what is the ionization state for phosphorus?
Well, P4 it is 0,
Okay. So
pH3 it
that
is minus 3,
yeah.
and H2PO2 minus it is plus 1.
Yes, sir.
It is again a
So
disproportionation reaction.
okay. So sir, but I thought we take the valency of PS4.
pH4?
So
P
the ionization number for P4 is 4, not
No,
0,
you
right?
can't. You have to take it 0 because it's elemental state. The oxidation state of every element in the elemental state is 0.
But so for Cl2 we took 2, right?
We didn't take it 2 as the oxidation state. We took 0 as the oxidation state. The change was 2.
Oh, yeah, yeah.
Okay? Because it was going from 0 to minus 1.
Yes, sir. So this is an acidic reaction, right?
Basic. It's OH minus
Oh,
written there.
yeah. So I got 3H2O plus 4P4 minus OH minus gives PS3 plus H2PO2 minus. Hello?
Yes.
Hello, sir?
Yeah.
Oh. Sir, I got 3H2O plus 4P4
Okay.
minus OH minus gives PS3 plus H2PO2.
How many PS3?
1 PS3, sir.
How could it be? You have on the left hand side 4. Yeah, that means 16P. So you haven't balanced phosphorus as yet.
Oh, yeah.
So you have done it wrong. You have to first of all balance phosphorus, then only anything else would be balanced.
Yes, sir. Oh, yeah.
Okay, do it again.
Sir, I'm getting 19H2O.
Rohan, first of all, what you need to do is you have to put it as P4 plus P4. Did you do that?
Yes, sir.
That gives us pH3 plus H2PO2 minus.
Yes, sir.
Okay,
Yeah.
now we get it like this. This 4, P4 gives pH3.
Yes, sir.
This P4 gives H2PO2 minus.
Yeah.
Okay. Now here the change is 12. Got
Sir,
it?
how do we get 12, sir?
There are 4 phosphorus and each is showing a change of 3.
Oh, okay.
And here the change is 4.
Okay, sir.
Now can you do it further?
Okay.
Do it.
Sir, sir, even after you take the LCM, you get, P4 plus 3P4, right?
Yes, you get it.
Yeah, after that I messed up again.
Do it stepwise, slowly.
Okay.
This is not an easy question, I do agree.
Sir, for balancing P4, sir, how do you balance P4? Do we multiply any number with P, or is there a number we should multiply with PS3 and also
See,
H2PO2?
this is going to become, this one is 12 and this one. So this is going to become 3.
Yes, sir.
Okay. So if this becomes 3, this becomes 12
Oh, oh, but sir, why does that become 12?
because it's 3 fours are 12.
Oh,
There are
fine.
12p here. Got it?
But sir, for the above one, for Cl2 plus Cl2, we didn't do that, right?
Yes, we did. There was 6 Cl2. There were 5 Cl2. So don't you think I made it 10?
Yeah.
And here it
But
was Cl2, I made it 2.
oh, but sir, while balancing, we got that right.
Yeah. Here again we are going to make it. This is going to become 4.
Oh, fine.
Okay?
Sir, oh, oh, okay. Sir, why did you multiply H2PO2 with 12, sir?
Because I considered it to be formed from 3p4. To balance phosphorus, I need to multiply it by 12 because I have 12 phosphorus on the left hand side.
Oh, so sir, we're balancing 3P4 and H2PO2 here.
Yes, because the arrow says so.
Okay, fine. Oh, fine. Sir, we have 24 oxygen molecules, right?
Yeah, then next step would be the balance oxygen molecule, oxygen atoms.
Yeah. So then we multiply 24 H2O.
Hmm.
Okay. Sir, we get 15 H2O plus P4 minus 9 OH minus, which gives PS3 plus H2PO2 minus.
Okay, so on the left hand side we have no oxygen, right hand side we have 24. So here we
Yeah.
have 24 H2O Now to balance these 24H2O, how many hydrogens do we have on the left side? There are 48. On the right hand side, here we have 12, and here we have 24. So we have 36. So here we need to put 12 H2O minus 12 OH minus.
Oh, yes, sir. Okay, sir. In the end, we get 3H2O plus P4 plus 3OH
Well,
minus.
let's see.
Okay,
So here we what we get. Here 12H2O, there 12H2O. So we are going to get 12H2O on the left hand side. So it's going to be 12H2O, okay,
yes, sir.
plus 12OH minus.
Sir, can't see that all the way down. I can see what you wrote until now.
Okay, the last one you are not able to see.
No, I'm able to see, sir. But if you go even more down, I won't be able to see it.
Fine then. I won't go any. Okay, I'll go on the top. Top you can see here.
Yeah, I can see that, sir.
Okay, so it's going to be 12H2O plus 12OH minus plus 4P4, giving us 4PH3 plus 12H2PO2 minus. Now let's
Yes,
take the charges. Here we have 12 negative charge, here we have 12 negative charge. So the equation is actually balanced. But what we can do is we can divide the entire equation by 4.
yes, sir.
So if I divide the entire equation by 4, it's going to become 3H2O plus 3OH minus plus P4 gives us PH3 plus 3H2PO2 minus.
Yes, sir.
So that is the balanced equation.
Yeah,
And this is what we call as a disproportionation reaction.
yes, sir.
Anything you would like to ask here now?
No, sir.
Okay. So let's do another kind of reaction.
Okay.
That's again a very simple reaction. We have H2S plus SO2 giving us S.
Yes, sir.
Now, Rohan, this is an opposite kind of reaction to this one. This was a disproportionation reaction where we had one reactant and two product.
Yeah.
Now, this is an opposite kind of reaction, and it's called a comproportionation reaction. Now, this is entirely reversed because this is a reaction in which there are two reactant giving one product, the two different oxidation state actually going to one. So it is reverse of disproportionation.
Yes, sir.
In disproportionation, what we were doing is we were writing the reactant twice. But here
Yeah.
we are going to write the product twice.
Oh, yes, sir. Sir, the oxidation state of S is zero, right?
The right side S is 0.
Yeah.
A simple reaction. Could you just balance it?
Yes, sir. Sir, is this a basic reaction?
It doesn't make a difference. It's acidic as such because we have H2S, which is an acid.
Okay, sir. Yeah, yes, sir. 3s plus 2H2O gives 2H2S plus SO2.
What do you said?
Sir, 3s plus 2H2O.
3S?
Yes, sir.
Why did you reverse it? S is on the right hand side.
Oh, yeah, yeah. 2H2S plus
2H2S.
plus SO2, sir,
Huh?
gives 3S
Huh?
plus 2H2O.
Plus 2H2O. Right, it is balanced.
Yes, sir.
Okay. Ron, did we do this AS2S3 question?
No, I don't think so, sir. Oh, yeah, yeah, we did, sir.
Okay. Now, today a student asked me a real nice question. Okay.
Yes, sir.
And that would be the last question for this part. And we are going to move further.
Yeah.
I think the redox reaction topic would be over by now.
In Fiji, sir.
Fiji, whatever they have done, I believe you can understand it now.
Yes, sir.
Okay. Any question in Fiji that you would like to ask me?
No, sir. We didn't have school yesterday and today.
Okay. So I believe you are already ahead of the course that is being done in the school.
Yes, sir.
Okay. Anything that you have yet done in the school that you would like to ask me?
No, sir.
Okay,
Nothing.
then. Let's have one question. And that was a question that I liked. It was something like Cn minus plus NO3 minus in presence of H plus gives us NO plus CO2 plus H2O. Think over if you can think how to do this question.
So we can remove the H plus and H2O, right?
Yes, you can. The H plus is only going to tell you that this is an acidic medium.
Okay.
Yes.
So we take the transfer of electrons in N for NO3 minus and NO.
You need to check it out.
Okay.
Think over. In fact, NO is coming from two sources. It is coming from Cn minus also and NO3 minus also.
Yes, sir.
So you'll have to write NO twice.
Yeah. So in Cn minus, the oxidation number of carbon will be 4, right?
In CO2, it is 4. I
Okay.
would suggest that you don't take the carbon and nitrogen separately. Just take the carbon plus nitrogen as minus 1.
Okay.
The same thing you can do on the right hand side. You can just write NO once again and take carbon plus nitrogen and get the value.
So we take the Cn as minus 1,
Yes.
and then what do we do, sir?
What we do is, see, we write the equation once again. We write it like Cn minus plus NO3 minus gives us. NO plus CO2 plus NO. Okay?
Yes, sir.
Now what we do is we take this Cn minus giving us NO and CO2
Yes, sir.
and NO3 minus giving us NO.
Okay.
Now Cn minus, the total is minus 1.
Yes, sir.
And here NO is plus 2
Yeah.
while C is plus 4.
Yes, sir.
So from minus 1 we go to plus 6.
Oh.
The change is 7.
Yes, sir.
From NO3 minus this is plus 5
Yes, sir.
and this is plus 2.
Yes, sir.
The change would be
3.
minus 3. Now can you start balancing it?
Yes, sir.
Do it.
Sir, we get 10 NO plus 3 CO2 plus 5 H2O, which gives 7 NO3 minus plus 3 CN minus plus 10 H plus.
Okay, let us check it out.
Yes, sir.
So here we are going to have 3Cn minus, we are going to have 7NO3 minus. Now from Cn minus we are getting carbon, so it is going to be 3CO2. From this N we are going to get NO, so this is 3NO. From this 7NO3 minus we are getting this NO, so this is 7NO again.
Yes, sir.
Okay. Now on the left hand side we have 21 oxygen. On the right hand side we have 3 plus 6, 9, 9 plus 7, 16
Yes,
oxygen.
yes, sir.
So here we are going to have 5H2O,
Yeah.
right?
Yes, sir.
And here we have 10H plus.
Yes, sir.
We can check the charges. Here we have 3 negative, 7 negative, total 10 negative, plus 10 positive, 0. And here we don't have a charge. So it is balanced. The equation is balanced.
Yes, sir.
And with that, we have just finished off with the balancing of the redox equation.
Yes, sir.
But we need to do a few questions more. Let us say one question we have.
Yes, sir.
The question is, how many moles of KMNO4 are required to completely oxidize 1 mole of FeC2O4 in acidic medium. Can you do this?
Yes, sir. So it's FeC2O4.
Yes,
Okay.
ferrous oxalate.
Okay. Sir, we can't balance Fe and C and Mn and K, right? Because there's no element on the other side for them.
You have to. You have to consider what the product is going to be.
Uh,
See, in the acidic medium, MnO4 minus go to Mn2 plus.
Sir, MnO?
MnO4 minus would form Mn2 plus.
Yes, sir.
And I believe we have already done the oxidation of FeC2O4.
Oh,
Turn the page and check it out.
yeah, yes, sir.
Do it.
Okay. So, sir, in acidic medium, MnO4 minus becomes Mn2 plus. So, KMnO4 will become KMn2 plus.
Now, KMnO4 is going to give you Mn2 plus. K plus is not going to change.
Okay.
You can just forget K plus. It's MnO4 minus giving you Mn2 plus.
Yes, sir.
What's the answer?
Sir, I'm not getting this one. One second.
Can you balance the equation?
No, sir. I'm not getting it.
The equation is straightforward one. We have MnO4 minus plus FeC2O4 giving in acidic medium, giving us Mn2 plus Fe3 plus CO2. Now can you balance it?
Oh, yeah. Okay.
Ron, you need to remember that in acidic medium it undergoes 5 electron change. In neutral it undergoes 3 electron change, neutral or basic medium.
Okay, sir. Sir, for FeC2R and Fe3 plus, the electron chain will be 3, right?
Fe?
Sir, FeC2O4 to Fe3 plus, the change will be 3. 3.
Yes, Fe3 plus CO2.
Okay. Sir, is it 3 MnO4 minus plus 2 FeC2O C2O4
5
gives 3
FeC2O4.
5?
Rohan, this is going to be, this change is 5 electrons,
Yes, sir.
while this change is 3 electrons.
Yes, sir.
So if you're going to do it, then in that case, it's going to be, here this is going to be multiplied by 3, this is going to be multiplied by 5.
Yes, sir.
And as far as the question is concerned, you don't need to do anything more than this.
Oh,
5 mole of FeC2O4 will react with 3 mole of KMnO4.
oh,
So 1 mole will react with 3 by 5 mole of KMnO4. So answer is 0.6 mole.
O- Okay, sir.
Is this clear?
Yeah. Yes,
Any
sir.
any confusions with that?
No, sir.
So Rohan, tomorrow you have a break. You are
No,
going to
no, sir.
school.
Yeah, there is school tomorrow.
Okay, fine enough. Now you have to do some work. And what's the
Yeah.
next chapter that you are supposed to do?
Sir, they didn't give us the
Schedule.
phase two books. Yeah, they didn't give us the next schedule yet.
Okay. So we have just finished off with the rocks reactions and we don't know what the schedule is. Have you done your Fiji topics?
Yes, sir.
Any problems with that anywhere?
No, sir. Actually, sir, all the doubts are in class only people ask. So I don't have any doubts to ask you, sir, separately.
Fine. And have I been helping you with the understanding in what Fiji does?
Yes, sir.
Is it easy to understand there now?
Yes, sir. It's easier.
Okay. Okay, Rohan, then I believe by Saturday you would be knowing what needs to be done.